Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, January 3rd, 2021, Monday. And this is now 4:10 in morning time, 4:10 a.m. मैं सूरज सिंह भारत इंडिया से बोल रहा हूँ. अभी आज जनवरी 3, 2022, 4:12 और I am back to you with same topic of quality and safety along with engineering and life. Title construction, designs and construction methods and disputes. As usual, starting with same spirit, here is my email ID suraj_engineer. Here is this at yahoo.co.uk. You can send to me mails if you are interested to know something about this topic or about issue. And these titles you can see very well. And here is certificate 1, professional engineers, is chartered engineers, and here is membership as well as quality. My gross interest, overall interest, is to intensively talk on quality. Quality that has gone down to certain level which doesn't please our country. Quality has gone down to such level that is deplorable. You can say, I'm saying gone down means it was somewhere there. Many years back, quality existed to some extent, but now it does not. 2022 has started, but we have not thought of that, and we are not. You can refer to whatever project in general. All products, irrespective of which field of engineering is that, do not amount to quality. It may be product that can be purchased, or it can be product that can be called service, or goods. You can say, just like you say goods, you get service or you get product, you won't be happy, you won't be satisfied. But all companies send you messages all companies keep sending you messages as if they have done excellent work for you, or they have provided you whatever others could not provide, and they want appreciation all time, and which is generally, you may say, it is quality procedures. And really it surprises me many times. They just maintain something, just provide a service for 10-15 minutes, and then they want to know how it was. Means they want to comment on that. Means they have to take time in commenting on their services, and which is not, means I don't think it is quality. You should be confident of your service, same way you should be confident of your product. As far as products are concerned, goods are concerned, I don't think, I'm not only thinking, it's experience, I think it is rubbish. I'm telling it for everyone, for all companies, big or small, particularly big companies, those who claim that they work at international level. I can say most nowadays, if you see big companies, for example Airtel, likewise HP, and like that, you take big companies, you will find these big problems in quality. I can't comment on lower class organizations because their personal attention is involved. But if you take national, big national or considerable national level companies and international level companies, I think all are same, no difference. It's only name now, nothing else. Only for name's sake, because generally they buy products from lower profile people or ask them to manufacture. It happens, I talk to many salespeople and many serving engineers what's problem with quality, and what feedback I got is that they are not interested in doing work themselves. They are very big, they just hire people or they just give subcontracts, supplies contracts or service contracts to others, and that's it. And that I think is first reason in quality drop, particularly in our country. Currently quality is at its minus level, not even at zero level. That's what I can say. I can't find quality, and that's my problem, and not only my problem, everybody's problem. And in particular, it's responsibility of engineers who should feel, who should do something towards this. But I think engineering community is also sleeping. What reason exists there? I have no clue for that. I therefore call that in Bharat, India, which is my original country, where I was born, when I saw in my childhood, there was something in the youth, when I was young, there was some fear in minds of people for doing quality work or specified work. But now fears don't exist because of computerized world. More and more computerization is ongoing, and I can say proportionally quality has been falling, or even improportionally quality has been falling. You cannot trust any product, you cannot trust any service. No regularity, no punctuality, no response, and whatever is specified on product, that is not warranted, except that you have warranty time. And some people don't even warranty because of many reasons. I don't know. I don't want to name anything as such, but it's really surprising, and I can say disappointing conduct. It's duty of government also to look after into such matters. Our government of this country, I can simply say, has been careless, has been ignorant. There is no control from government level, because when there is just maybe it exists in papers, but in reality no control exists. The government charges taxes from everybody, income tax, and you can say other taxes, GST, house tax, or whatever they charge. They charge taxes on every product. I don't know reason of that tax. If the government doesn't work, if government doesn't care about what quality goes on, and in that case, if your products do not tally with quality requirement, do not fit in, no other country shall buy your product, and you cannot call yourself industrious country, because industrial country means you should be good in your production, and that's meaning of industrial country. Otherwise, if you are not industrial country, nobody shall buy your products. Why should somebody buy your products when you don't produce quality products? And that's where my concern is. Is it to politically say that we have this much economy, our target in so many years, but that is only on dreams? And we say dreams have to come true, and dreams can come true only with dedication, with commitment, you can say standardizations, and with hard work. Without hard work, you can't have dreams come true. We have to realize this fact also. And that's why I write sometimes my pages in both languages. And you can see this language in our countries, you can say official, and you can say people's language. It's not exactly, you can say it's not pure Hindi or what I'm trying to communicate myself. Communication is also required. And I can say that exists no quality. Where does quality exist? And where is in our country quality existing? Where is quality? And this is the responsibilities of engineering community to look after this, because most products come from engineering. It may be civil engineering product or mechanical engineering or electrical engineering, all IT or all others product. Whatever products we get, it comes through certain procedures, certain specifications, certain standards. It's not simply, even you buy water bottle, it has got certain specifications. If you buy it wet floor or you buy something else, whatever electronic product, everyone has certain lifetime and some specifications, without which these products cannot be delivered, cannot be purchased, cannot be sold. But purchasing and selling is not requirement here. Requirement is How does product perform? Product performance is very important. There is only certification. You can say I'm certified when my product I certify, but even your certification doesn't value because what you say doesn't work. Performance is more important in engineering world, and we say if you don't perform, you are not suitable for this job. We generally say we recruit you. It generally happens. Okay, we recruit you based on your interview or examination, and we will see, we'll look after your performance. We will observe your performance. If performance comes to mark, then we will regularize you, or we will keep you for our contract. It's only for 1 month or 2 months or 3 months or 4 months. This probation is required, and you have to pass through the probation. Whatever times, how many times you join a job, you may change a job, even though your experience, but your performance is very important. So that's what criteria is fixed. If your performance is to be observed, the performance of product is also to be observed. And that's why I say performance. It may be personal performance, it can be officers' performance, it can be managers' performance, it can be MD's performance, it can be engineers, doctors' performance. So whatever performance required, that's very important. So as product performance. If product does not do that, in that case it is shameful, and we only keep ourselves under cover of warranty. I don't respect warranty if it is only for namesake or it's only for your own protection of sailors, that okay, you have 1 year or 2 years warranty and I help you. If I help you, it's your responsibility that you replace that or repair that. Why should something go I mean say without performance or successful performance? You paid to you, I paid to you, not for warranty, I pay to you for life of product. If product is 5 years, then it should not go wrong in 5 years. It should, but okay, in rare cases I can say fine. One in, because there are 5,000 items and one item goes wrong, you may say okay, here after 5,000 it happens, but it happens every item. Means you have to either call you in a couple of months. Okay, this is not working. Come and repair it. And you say okay, I'll repair. It's my responsibility. Your responsibility was that you should perform for lifetime without any fault, but it doesn't happen. That's why I'm saying, well, it's all business, it's all management, you can say organization. I think since management appeared in world, since these management professions, you can say, I can't call them profession, management studies appeared in world, I think quality has gone down. Because management people do not care for quality, that's what I understand. And engineers particularly who are qualified, who are educated, they jump to management and they spoil engineering, they forgot engineering. Eventually it's happening that people, students and you can say engineers come out colleges, they jump to management or IT. And when you join IT or management education, well, I think you are off track of real engineering. I don't consider IT as engineering because IT is science, it's not engineering. In fact, everybody knows it. It's more on side of sciences and not engineering. And you cannot say that that's a trial. You can every IT software is a trial based. Every 3rd month, 4th month, you say there's update. Why should there be update? Because this never ending procedure, and we can say computers don't work even satisfactorily. Many times they hang. So till today, we don't find any software to perfect. Well, that's not my point of view. My point of view is life product, and I, being a civil engineer, I'm very much interested in that and concerned also of structures. We don't find quality in our productions or production structures and finishes and lifelong service we get from whatever structure. And we are having vast world. And that's why I'm very much concerned about that. If I jump onto concrete specifications, I talked yesterday, we went on to this, we talked of concrete, and this is concrete specifications. I refer to this from Qatar, and I think this is a good one for me. I think so. This is discussed, we conferred, we debated. You can't say debate, we deliberated. This is aggregates, cement is just materials, water, admixtures, property, requirements, concrete plants, transportation and placing of concrete, formwork, curing, reinforcement, and you can say construction joints, inspection and test of hardened concrete, protective coatings to concrete, hot weather concrete, miscellaneous, precast concrete, pre-stressed concrete, water retaining structures, general quality assurance or requirement and quality control. I am just trying to add always, I'm trying to always add quality requirement rather than quality assurance, because requirement is important, assurance is not important. I don't trust the assurance, the time has gone, assurance and assurance. So I say quality requirement and quality control. Foundations and retaining structures, roadworks, drainage works, mechanical and electrical includes requirements of concrete work for pipelines, roadworks, runways, structures. This is general it is, and part 1 general. So likewise we can see these are the here, then section 1 is general, all this, and then we have many references we have gone through, lot of references, and this we have gone through. I will not go through scanning. I will, and we can say field various, you can say whole page. If you scan, you will find that lot of that we have gone through. It's not complete, it's just only, you can say some references. Now last time what I was thinking and doing is that you see what I was interested, I was took many files down from you can say internet to understand what we have to do, how we have to do concrete in certain weather conditions. And that's point where you may say we have to understand clearly, because concrete is very important item. It's such an important item that even very experienced people don't understand concrete. Sometimes it happens. I have files here, concrete guide to visual and architectural concrete, then it is ACI concrete technology terms, then best practices for cold weather condition concreting, chemical reactions in polyolanic concrete, cold weather concreting, and we have here, you know, what I mean to say, I'll see cold concrete weather condition and cold and the concrete diaphragm wall. So let's say first of all, I open this file. As a file that I'll refer to that. Let me see concrete terms. I'll show what I will discuss later on. That's here. I can say I will discuss later on, but I'm just trying to show you here for reference first. This is a long file, but we'll discuss it. And to discuss that, first we have to make certain background of certain items. This is, you can say, file from ACI, that is American Concrete Institute. This is called ACI Concrete Terminology. This is a long file, about 80 pages. And what we have to understand from this, first of all, it was printed September 2021, American Concrete Institute. Tries to avoid ambiguities, omissions and errors in these documents. In spite of these efforts, users of ACI documents occasionally find information or requirements that may be subject to more than one interpretation or may be incomplete or incorrect. Users who have suggestions for improvement of ACI documents are requested to contact ACI. Okay, ACI committee, all this is introduction, so just for information which I'm just referring to, because I cannot hide something when I use this. So this is that file, and it's on behalf of American Concrete Institute. This is now it's American Concrete Institute Concrete Terminology, ACI CT21. In this, various definitions are given. For example, first one is AF ratio, molar or mass ratio of aluminum oxide Al2O3 to iron oxide Fe2O3. As in Portland cement, AF ratio is called aluminum, you can say AF ratio Abraham's law, a rule stating that with given concrete materials and conditions of test ratio of amount of water to amount of cement in mixer determines strength of concrete, provided mixture is of a workable consistency. and it's called water cement, as we know, but it's the prime slide. Similarly, we can say there is another one, abrasion damage. Abrasion damage, you can say abrasion damage, wearing away of rubbing, by rubbing and friction, and it's called abrasion damage. Same way, abrasion resistance, it is called, and we can say, I'm just giving references only, few references, just to let you know what I have programmed to talk about. Abrasion resistance is ability of a surface to resist being worn away by rubbing and friction, and abrasion resistance is ability of a surface to resist being worn away by rubbing and friction. So one was damage and one is resistance. So damage is, for example, wearing away of a surface by rubbing and friction, and his resistance is the ability of a surface to resist being worn away by rubbing and friction. And absolute volume, in case of solids, displacement volume of particles themselves, including their permeable and impermeable voids, but excluding space between particles. In case of fluids, their volume. So likewise, we have to know absorbed moisture, absorbed water absorption, accidental air acid etching, acrylic resin, active crack additive adhesion, adhesives, and you can say adiabatic mixtures absorb water. Then is the terminology is absorption, advancing slope grouting, advancing slope method, aerated concrete, affiliate agent, agglomeration, aggregate blending, aggregate degradation, aggregate interlock, aggregate transparency, aggregate cement ratio, agitating speed, agitating truck, agitation, agitator, air content, air entraining, air entrainment, airlift, air meter, air ring. Then we have air separator, air voids, air blown mortar, air cold blast, air permeability test, air water jet, alignment fire, light, alkali, alkali reactivity of aggregate, alkali aggregate reaction, alkali carbonate rock reaction, alkali silica reaction, alkyl aryl sulfonate, allowable bearing capacity, allowable lead load, allowable stress, alternative cement, alumina, aluminate cement, aluminate concrete, aluminous cement, amount of mixing, amplitude, anchor bolt, anchorage bond stress, anchorage deformation, anchorage devices, anchorage loss, anchorage slip, anchorage John angle of response. Calcium chloride, CaCl2, anti-washout mixture, apparent specific gravity, arc, arc, you can say arc spectrography, architect engineer, then architectural concrete, area of steel, Arnesius, Argillaceous aris, arising tool, artificial pozzolana asbestos cement products, and likewise we have here ashlar machinery, asphalt cement, asphaltic concrete, atmospheric pressure steam curing, autoclave, curing, autoclave cycle, autoclave aerated concrete, autoclaving, autogenous healing, autogenous length change, autogenous shrinkage, autogenous volume change, automatic batcher, auxiliary reinforcement, average bond stress, axial load, axial steel reinforcement, and back form, and back plastering, backstay, backfill concrete, balanced movement, balanced reinforcement, ball mill all test, bar bender, bar math, bar schedule, bar spacing, bar support, bar and check, barite, barrel of cement, base, base bead, base coat, base course, base plate, base screed, basic creep, basanite, batch mixer, batch plant, batch weight, batch to water, batcher, and we have there, you can say descriptions of this: batten, battle, pile, bauxite, bay, beam bottom, beam pocket, beam test, beam column, bearing capacity, bearing stratum, belite, ballad, PR, ballad, bending moment, and bending moment diagram, bending factions, bend bar, bentonite, billet, Blaine apparatus, Blaine fatness, Blaine task, blast, furnace slag, and likewise we have uh, bleeding capacity, blast furnace. You can say, oh no, something has gone wrong. I'm sorry. I put the wrong button here. Sorry, here something wrong. Something went. So excuse me for that. I was on B. So I came back to here. It's base course, basic plate, base screed, basic creep, basanite, batch mixer, batching plant, batch weight, batch washer, batchers, batten pile. So I came back here, and he say bentonite, billet, steel binary mixture binder, biological shielding, bituminous cement, Blaine apparatus, Blaine fineness, then Blaine test, blast furnaces lag, bleeding capacity, bleeding rate, blemish, blended cement, binding, bleeding capacity, bleeding rate, blemish, blended cement, blinding, blistering, block beam, block out, blow holes, blow pipes, blow up, board butt joint, ball sleeve, bond area, bond breaker, bond length, bond plaster, bond prevention, bond length, bond stress, bonded hollow wall masonry, bonded member, bonded post tensioning, bonded tendon, bonding agent, bonded member, bond with post tensioning, bonded tendon, bonding agent, bonding layer, board pile, boring, boron pits, boron loaded concrete, box out bracing, bracket, bridge, brick seats, bridge deck, briquette, broadcast, broom bnish, brown coat, brown out, brown millerite, bruised surface, buckling, bug holes, buggy, building official, build up, bulk cement, bulk density, bulk specific gravity, bug holes, buggy, building official, build up, bulk cement, bulk density, bulk specific gravity, bulk head, bulking factor, pull float, bundle, bush hammer, butt joint, buttress, butyl sterolite, and cable, cage, cation, calcareous, calcite, calcium sulfo aluminate cement, very important point, calcium sulfo aluminate cement, calcium chloride solution, calcium hydroxide, calcium stearate, calcium aluminate cement, calcium silicate brick, calcium silicate hydrate, calation, California bearing ratio, calorimeter, camber, canister type, anchor bolt, cant strip cap, capacity reduction factor, capillarity action, capillarity pores, capillary rise, capillary suction, carbon black, carbonation shrinkage, cast stone, castable refractory, cast in place concrete, cast in situ cathode, cathodic protection, cork, cavitation damage, selite, and we can say cast in situ, cathode, cathodic protection, cork, cavitation damage, selite, cellular concrete, cellular construction, cement, bacillus cement, content, cement factor, cement gel, cement gun, cement paste, cement plaster, cement block, cement rock, cementation process, cement bound macadam, cementitious material, cementitious mixture, centering, central mixer, central mixed concrete, centrifugal process, centrifugally cast concrete, ceramic bond, chair, chalk, chalking, chamfer stiff, ceramic bond, chair, chalk, chalking, chamfer strip, charge, checking, chemical admixture, chemical attack of concrete, chemical bond, chemically pre-stressing cement, chaff, chipping chips, shoot, clamp, class of concrete, classifier, clay content, clean out, clean up, cleat, climbing form, clinker, check clip, coarse aggregate factor, cleat, climbing form, kicker, coarse factor, and then coarse grained soil, coated bar, coating, cobble stone, coefficient of permeability to water, coefficient of subgrade friction, coefficient of subgrade reaction, coefficient of thermal expansion, coefficient of variation, cold joint, then cold strength, cold weather, cold drawn wire reinforcement, and you can say cold joint lines, cold joint steel reinforcement, collimanite, collected fiber, colloidal grout, colloidal mixer. Then you can say cold joint lines, colloidal mixer, and then you have color hardener, colorimetric value, column capital, column clamp, column side, column strip, combined footing, combined aggregate grading, come along, compacted strand, compacting factor, compaction, composite column, concrete flexure member, composite construction, composite, it is composite concrete flexural member, that is composite construction, composite pile, composite sample, compression member, compression reinforcement, compression test, concentric tendons, concordant tendon, concrete block, concrete breakdown failure, and you can say concrete brick, concrete cart, concrete compressive strength, concrete containment structure, concrete cover, concrete finishing machine, and you can say here is also concrete die, which concrete die, concrete finishing machine, concrete flat work, concrete masonry unit, CME we call it, concrete paver, concrete pile, concrete producer, and we can say here concrete pry-out strength, concrete pump, concrete reactor vessel, concrete spreader, concrete strength, concrete vibrating machine, condensed silica fumes, cone bolt, confined concrete, confined region, consistency factor, consistometer, consolidation, consistency factor, and we can say consistometer, consolidation, construction joint, and also we can say here, let me check it's yes, working, still working. So consolidation, construction joint, there is construction loads, contact ceiling, contact pressure, contact splice, containment structures, continuous beam, continuous you can say grading, continuous mixer, continuous mixing, continuous sampling, continuous slab beam, continuously reinforced pavement, contract documents, contraction joint grouting, contractor, control joints, and you can say conveying hose, conveyor, coping, cobble, core, and you can say core beam, coring, corner reinforcement, corrosion inhibitor, cotton mats, coupler, coupling agent, coupling sleeve, course, crack, gesture, crack control reinforcement, cracked section, cracked section, and you can say cracking load, cracks, gracing, creep, critical saturation, cross bracing, cross section, and we can say cross plate, crushed gravel, crushed stone, crusher, run, aggregate, cube strength, cumulative batching, curing agent, curing blanket, curing compound, curing cycle, curing delay, curing kiln, curing membrane, curling, cutting, grouting, curvature friction, cutting, screed, cuttings, and we can say here cylinder strength, damage, dam proofing, we have thereby Desmond coat, David decracking, that end, that load, that end anchorage, dead man, debonding, decentering, decking, decorating concrete, and deflected tendons, deflection, deformation, deformed bar, deformed reinforcement, deformed tie bar, dehydration, daisher, and we have delamination, we have delamination, delayed, attringite formation, delivery hose, demold, that is demold, we have, this is here, demold dense graded aggregate, and we have densifier, density dry, density control, design bearing pressure, and we can say design bearing pressure, design load, design strength, detailing deterioration, and we have here development, bond length, bond stress, development length, devil's float, diagonal cracking, diagonal tension, diametral compression test, diamond mesh, diatomaceous earth, and we have dicalcium silicate, differential thermal analysis, diffusion, dilation, and we have direct dumping discoloration, we have differential thermal analysis, and we have, of course, we have done it. Then we have disintegration, dispersing agent, distortion, distress, distribution bar, reinforcement, D-line cracks. We have here dome, dormant crack, double T-beam, double up, dowel road, double bar reinforcement, and drainage fill. We have drap tendon, as a drainage fill, drap tendons, dryer, drilled pier, drilled pile, drilled incation, drip, drop panel. We have here drop chute, and dry mix, dry mixing, dry pack, dry packing, dry process, and of course dry rodding, dry topping, dry batch weight, dry cast process, dry mix shotcrete. We have here dry packed concrete, dry rodded density, dry rodded volume, dry rodded weight, dry shake, dry ramp process, drying creep, drying shrinkage, ductility, and Dunagan analysis. Dunagan analysis, durability and durability factor, dust of fracture in aggregate, dusting, dynamic analysis, dynamic load and dynamic loading, dynamic modulus of elasticity, early age of concrete, early stiffening, early strength, early entry, dry cut saw, dynamic then eccentric tendon, edge beam, edge form, edge reinforcement, edging, effective area of concrete, effective depth of section, effective flange width, and effective pre-stress, effective span, effective stress, effective width of slab, a floor sense, elastic design, elastic limit, elastic loss, and elastic shortening, elasticity, electrical curing, electrolysis, electrolyte, elephant trunk, elongated piece of aggregate, and we can say elongation, detail, emulsion, and there is enclosure wall, encrustation, and anchorage and block and bearing sleeve, endothermic reaction, engineered cementitious composite, then entrained air, entrapped air. We have environmental engineering concrete structures, epoxy concrete, epoxy concrete, epoxy grout, epoxy mortar, epoxy resin, epoxy coated bar, equilibrium density, equivalent embedment length, equivalent fiber diameter, equivalent rectangular stress distribution, erosion, etheringite, evaporable water, evaporation reducer, evaporation retardant, and you can say exfoliation, exothermic reaction, expanded blast furnace slag, expanded shale, clay or slate, expanded metal fabric reinforcement, expanded metal lath, expansion joint, expansion sleeve, expansive cement, expansive component, exposed aggregate finish, exposure class, extender, extensibility, exterior panel, external vibrator, extreme compression fiber, extreme tension fiber, exudation fabric, factor of safety, factor load, false header, false setting, false work, and we have here fascia, fastener, fatigue, failure, fatigue strength, faulting, feeder edge, feed wheel, ferro cement, and we have here ferro cement, fiber aspect ratio, fiber count, fiber reinforced concrete, fiber reinforced polymer, field bending, field concrete, field cured cylinder, field proportioned grout, fillet fin, final curing, final pre-stress, final setting time, final stress, fine aggregate, and we have fine grained soil, finishing grinding, we have finished screen, finishing, we have here finishing machine, fire clay, fire resistance, fire strength, flash coat, flash setting, and we have here fire resistance, fire strength, flash coat, flash setting, flashing, flat jack. We have here flat piece of aggregate, flat plate, flat slab, flexible pavement, flexural bond stress, flexural rigidity, flexural strength, flint, float, finish, floating, flow, and we have flow cone, flow line, flow table, flow trough, flowable consistency, flowing concrete, fluid consistency, fluidifier, fly ash, flying foam, formed concrete, fog curing, fog room, folded plate, footing, form anchor, form coating, form hanger, form insulation, form lining, form oil, form pressure, form release agent, form spacer, form spreader, form tie, formwork engineer, contractor, formwork tire, foundation bolt, fracture, free fall, free lime, free moisture, free water, fresh concrete, Fresno travel, friction loss, friction pile, frog, Fuller curve, Fuller, Thompson, ideal, grading curve, furring. And we have furring, ganged forms, gap, graded aggregate, galenite, geopolymerization, and we have here Gilmore needle, girder, glass transition, temperature, go double, grab, setting, gradation, grade beam, and here we have grade beam, grade strip, graded standard sand, gradient, grading curve, granulithic concrete, and we have here granulithic finish, then granulated blast furnace slag, gravel, green concrete, then grid foundation, then we have grinding, then grinding aids. We have grinding and grinding aids. Grinding medium, grizzly, grog, groove joint, groover, ground wire, ground granulated blast furnace slag, ground granulated blast furnace slag, grout slope, that is grout slope, grout masonry, grouted aggregate concrete, grouting, gun finish, gunite, gunman, gunning, gypsum plaster. Then we have hairline crack, hairpin, ham tip, hanger, hard burnt lime, hardened concrete. And we have here hardened concrete, hardener, hardening, hardy cross method, harped tendon, harsh mixture, haunch hock. Then we have here, haunch hock, head anchorage capacity, head bearing area, headed bar, header, heat of hydration, heat of solution, heat, deflection, temperature, heating rate, heavy concrete, heavy media separation, heavy weight aggregate, heavy weight concrete, helical reinforcement, hematite, hemihydrate, hesitation setting, Hessian, high alumina cement, high density concrete, high discharge mixer, high early strength cement, and we have here, you can say, has a high early strength concrete, high fineness cement, high lift grouting, high performance concrete, high pressure steam curing, high range water reducing admixture, high strength high range water reducing admixture, high strength concrete, high strength reinforcement, high strength steel, high temperature steam curing, hard hold down bolts, hollow unit masonry, honeycombing, honeycomb, Hooke's law, hook bars, hoop reinforcement, horizontal shoring, horizontal shaft mixer, hot cement, hot face, hot load test, and we can say higher effect, hydrated lime, hydration, hydraulic cement, concrete structure, hydraulic hydrated lime, hydraulic cement grout, hydromix nozzle, hydrous calcium chloride, CaCl2, 2H2O, ignition loss, ilmenite, impact hammer, impending slough, inclined axis mixture, incrustation, indented wire, initial curing, initial press test, initial setting time, initial stasis, insert, in situ concrete, insoluble residue, insulating concrete, internal curing, internal vibration, and we have here inverted L beam, inverted T beam, I section, isolation joint. To different one, jacking device, jacking force, jacking stress, jacking stress, jaw crusher, jitterbug, joint filler, and we have here joint sealant, joint spal, jointed detail, jointer, that's concrete jointing, joint sealing compound, joist, kaolinite, Calibal, and we have here Carnaria, keyway, kick step, kicker, kiln, lacing, legging, latins, lap splice, lapping, reinforcing steel, and we have lateral reinforcement, latex, layer, L-beam, leaf, lean concrete, lean mixture, lacher, length change, lever arm. And here we have licensed design professional, lift joint, lift slab, where we have lift slab, lightweight aggregate, lightweight concrete, limestone, limit design, limonite, linear transformation, linear traverse method. And we have here lining, lintel, live load, load balancing, load factor. We have here load balancing, load factor, load bearing wall, long column, longitudinal bar, longitudinal crack, longitudinal joint, longitudinal reinforcement, Los Angeles aberration test, loss of low density concrete, low heat cement, low lift grouting, low pressure steam curing, low strength material, machine base grout, low machine base grout, and this is macro fiber, macroscopic, visible to naked eye, that's macroscopic, and then it is, magnetite, manual batcher, manufactured sand, map cracking, marble, and masonry, cement, masonry grout, masonry lift, mass concrete, and then we have here mass concrete, mass density mat, mat foundation, material hose, matrix, then we have maturity factor, we have maximum size of aggregate, mean stress, and here we have mechanical anchorage, mean stress, and we have mechanical anchorage, mechanical bond, mechanical connection, mechanical lap splice, megascopic. We have melilite, we have here melilite, and here melt, membrane curing, membrane theory, mervinite, mesh reinforcement, mesh roller, mesh nature hinge, and we have here metacoulin, micro concrete, micro cracking, micro crack, microfiber, microscopic, microsilica, micro topping, middle strip, mill scale, and we have mineral aggregate, mineral fill, and here efficiency, mixing cycle, mixing plant, mixing speed, mixing time, mixing water, mixture proportions, mobile placer, mobility, moderate exposure condition, moderate sulfate resisting cement, modified cube, modified Portland cement, modular ratio, modulus of resilience, cabinet, moist room, moisture barrier, moisture content of aggregate, moisture free mold, movement distribution, monolithic concrete, monolithic surface treatment, monolithic topping, monomolecular, Mount Morellonite, mortar board, mortar flow, mosaic, mottling, moving forms, mud mat, mud pumping, mud jacking, multi-element processing, nailer, natural cement, natural pozzolana, natural sand, neat cement grout, neat cement paste, neat plaster, negative movement, negative reinforcement, net cross-sectional area of masonry, net mixing water, neutral axis, neutral refractory, no fines concrete, nodal zone node, nominal fractural strength, nominal maximum size of aggregate, nominal shear strength, nominal size, nominal strength reduction factor, non-agitating unit, non-air-intent concrete, non-bearing wall, non-combustible, non-evaporable water, non-ferrous, non-pre-stress reinforcement, non-recoverable creep, non-tilting mixture, non-volatile content, normal cement, normal consistency, normal Portland cement, normal stress, normal weight aggregate, normal weight concrete, no slump concrete, nozzle liner, nozzle velocity, nozzle band, obsidian, offset band, offset yield strength, oil well cement, one way system, opal line chart, open graded aggregate, open top mixer, ordinary Portland cement, orthotropic, owner's representative, oven dry specific gravity, overlay, over sanded, over spray, over vibration, owner, pack setting, package concrete mortar or grout packer, head process, paddle mixer, pan mixer, panel strip, paraffin patch, partial pre-stressing, particle shape, particle size distribution, parting agent, pass, paste content, paste volume, pattern cracking, pattern cracks, pattern ashlar, pavement concrete, paving train, P gravel, peak load strength, pedestal peeling, pencil rod penetration probe, penetration resistance, percent fines, percentage of reinforcement, performance-based application specification, performance-based specification, periclass, perlite, permanent setting, permeability, pervious coat, concrete, pervious pavement, petrography, petrology, phenolic resin, phi factor, and physical salt attack, pier cap, measurement of pigment, plaster, pile bend, pile cap, pipe column, pile pitting, placeability, placement, placing, plain bar, plain concrete, plain masonry, plain pavement, plane of weakness, plaster of Paris, plastics, plaster of Paris, plastic cement, plastic consistency, plastic hinge, plastic flow, plastic plastic hinge, plastic shrinkage, plasticity index PI, and we can say plasticizer, plastic shrinkage, crack, plumb, pneumatically applied mortar, point count method, modified, point load, point of counterflexure, point of reinflection, point of counterflexure, point of inflection, Poisson ratio, polarizing microscope, polish or final grind, polished concrete, and polyethylene and polymer concrete, polymer cement concrete, polymer impregnated concrete, polymerization, polystyrene resin, polyurethane, polyvinyl chloride, ponding, poppert, porosity, Portland blast furnace slag cement, Portland cement, crack clinker, Portland cement concrete, Portland, pozzolana cement, position, coupler, positive moment, positive reinforcement, pozzolana, pozzolanic reaction, pozzolanic activity index, pre-blended grout, precast concrete, precast pile, pre-compressed zone, pre-fire, preformed foam, pre-mature stiffening, pre-placed aggregate concrete, pre-post tensing, preservation, preset period, pre-shrunk concrete, mortar grout, pressed edge, pre-steaming period, pre-stress concrete, pre-stressing steel, pre-tensioning load, pre-tensioning concrete, pre-stressing steel, pre-tensioning of bench, primary crusher, principal planes, principal stress, probable fractional strength, probabilistic design, proposition, proportional limit, protected waste volume, pug mill, pull-out failure, pull-through failure, pulse, velocity, pulverized fuel ash, pumicite, pumpable concrete, pumping of pavements, punching shear, putty pride, quality assurance, quality control, quick setting, quick line, railed steel, enforcement, ramming, and we have here ramming, random slur, quality, random slur, raveling, raw mixer, relay wave, reactive aggregate, reactive silica, reactive stain, ready mix concrete, rebar, rebound, hammer, recycled concrete, reference standard, refractory is refractorians, refractory aggregate, refractory concrete, refractory insulating concrete, regulated set cement, rehabilitation, reinforced concrete, reinforced masonry, reinforcing bar, reinforcement ratio, reinforcing bar, relative humidity, and we have release agent, remoldability, remolding test, render, repair. We have repeatability, reproducibility, require the average strength, resetting of forms, reshore, residual deformation, residual strength, resilience, resin, and we have resin, concrete, resin mortar, restoration, restraint of concrete, retardation, retarder, retarding admixture, redamper, reveal, revive, rib slab, ribbon, loading, rich concrete, rich mixture, rider, rider cap, rigid frame, rigid pavement, rigid pier, rock, pocket, rod, and we have rodding, roller compaction, roller compacted concrete, rotary float, rotary kiln, route, rubbed finish, rubber setting, rubbing brick, rubble, rupture modulus, rupture strength, rustication strip, R value, sag, sag rub, sagging sample, we have sampling plan, sand equivalent, sand pocket, sand streak, sand lime brick, sandstone, sandwich panel, Santorin earth, saponification, saturated surface dry, this is saturated surface dry, bulk specific gravity, saturated surface dry particle density, saturated surface dry specific gravity, saturation, and then socket, sawdust concrete, sawed joint, scaffold, scaling, scalping, grease screen, scanning electron microscope, scarf connection, Smith's hammer, scoria, scour, snatch, coat, screed, screed guide, screed rails, screed wire, skidding, screed, sealant, sealer, sealing compound, seating, secondary crusher, segmental construction, segregation, self-consolidating concrete, and we have self-desiccation, self-furring, self-stressing concrete, mortar or grout, salvage, semi-automatic batcher, sensor, separation, service, dead load, service, live load, service load. Then set accelerating admixture, set retarding admixture, setting, and we have setting time, settlement, settling, severe exposure condition, shale, sharp sand, she bolt, shear, shear cap, shear enforcement, shear strength, shear stress, shear head, shear wall and sheath, sheathing, sheath pile, sheathing, shelf angles, shielding concrete, shim, shooting, shore, shoring, shoring layout, short column, shorten, shotcrete, rebound, shoulder, shrinkage, shrinkage crack, shrinkage cracking, shrinkage loss, shrinkage reinforcement, shrinkage compensation. We have shrinkage compensating cement, shrinkage compensating concrete, shrinkage mixed concrete, shrink mixed concrete, SI System International, side face blowout failure, and sieve analysis, sieve fraction, sieve number, sieve size, significant, silica floor, silica fume, silica powder, silicate. And then we have here siliceous aggregate concrete, silicone, silt, simple beam, single sized aggregate, sintering, skid resistance, slab bolster, slab strip, slab jacking, slab on ground, slag, slag cement, slag activity index, slack time, slat, slate, sleeve, slender beam, slender column, slenderness ratio, slick line, sliding form, slip form, slope footing, sloughing, slugging, slump cone, slump loss, slurry, smack tight, snap tie, snow load, soffit, soil, soil cement, soil pressure, soil stabilization, solid masonry unit, solid span length, span depth ratio, spandrel beam, spatter dash, specialty structural engineer, specific gravity, gravity factor, then specific heat, specific surface, specification in ASTM, specified compressive strength, specified concrete compressive strength, specified concrete equivalent strength, specifier, specimen, then we have spinning, spiral, test, standard hook, standard hooked bar, standard sand, standard time temperature curve, static load. We have static modulus of elasticity, stationary hopper, steam curing, stearic acid, steel sheet, steel trowel, stencil, patterned concrete, step footing, sticky cement, strip back stiffness strap, stoichiometric, stone sand, storage hopper, straight edge, straight line theory, strain hardening, strain softening, strand, strand wrapping, stratification, straddling compound, strength design method, stress corrosion, stress relaxation, stress structural endpoint, structural lightweight concrete, structural load test, structural repair, structural sandwich construction. Sulfate resistant cement, sulfo-aluminate cement, superimposed load, superplasticizer, superstructure, sulfated cement, supplementary cementitious materials, surface active, surface area voids, surface area, surface bonding of masonry, surface moisture, surface retarder, surface air voids, surface area, surface bonding of masonry, surface moisture, surface retarder, surface tension, surface texture, surface vibrator, surface voids, surface water, surface active agents, surfactant, surface void, surface water, surface active agent, surfactant, sustained modulus. Synctite System International Talc Tamp Pose Process Tamper Tamping rod T-beam Teltake Tamper Temperature cracking Tarajo Concrete Test Tetracalcium Aluminoferrite Texture Texturing Thermal Conductance Thermal Conductivity Thermal Contraction Thermal Diffusivity Thermal Expansion Thermal Movement Thermal Resistance Thermal Shock Thermal Stress tie bar, tie rod, tie back, tied column, tilting mixer, tilt up, time of haul, time of setting, time dependent deformation, tie Tober molite gel, tolerance storm, then tolerance storm, tongue and groove, tooling, top form, topping, torque, viscometer, torsional stress, toughness, transfer, and transfer bond, transfer length, transfer strength, transit mixer, transit mixed concrete, translucent concrete, transmission length, transverse crack, transverse joint, transverse priestess, transverse water reinforcement, transverse strength, trap, lock. Turbidometer, turbidometer fineness, turbidite mixer, spin, twisted bar reinforcement, twisted steel, micro better, micro rebar. We have two ways. unbonded member, unbonded post tensioning, unbonded tendon, unbraced length of column under bed, undersanded, undersize, underwater concrete, unhardened concrete, unit masonry, unit water content, unit weight, unreinforced concrete, unsound, U value, vacuum bag, well bag, vapor barrier, webby apparatus, vehicle, Wiener, Vanitian, vermiculite, Vanitian vermiculite, vertical shaft mixer, vibrated concrete, vibration, vibration limit, vibrator, Y-cut apparatus, Y-cut needle, viscometer, viscosity, visual concrete, wide cement ratio, volatile material, volume batching, volume change, volumetric measuring, volumetric mixture, water cement, then we see waffle, Wagner fineness, whale, wall form, water, warehouse bag, warehouse setting, warping, warping, warping joint, wash, water, water blast, water pocket, water ring, water wide, water cement ratio, water cementitious materials ratio, waterproof cement, waterproofing compound, water reducing mixture, water repellent, water resistant, water stop, watertight wearing course, weathering, web bar, web reinforcement, wedge anchorage, batching, welded butt splice, welded wire fabric, weld wire reinforcement, welding, well grained aggregate, and wet process, wet and wet process, wet screening, cement, wind load, wind pile, wire mesh, wire wrapping, wobble coefficient, wobble friction, work ability, working load, working stress diagram, woven wire fabric, woven wire reinforcement, wrapping with sheaf, wrapping, we have woven wire fabric, woven wire reinforcement. Again, I say working load, working stress diagram, woven wire fabric, woven wire reinforcement, wrapping. Why the express, zonolithic, zonotite, X-ray diffraction, and we have X-ray emission, specific factors can say, this is X-ray diffraction, X-ray emission, spectroscopy, X-ray fluorescence, yellowing yield, and yield zero slump concrete, and I think this is again committee's introduction, you can say, and that's all we did today in this talk. And we have here let's continue. home, you will find we tried, this was just names I announced for which given in this terminology. We will go one by one later on. In this terminology, we will go one by one later on, and because it's may not feel bored. And we will now open another file. I will close this terminology file for time being. We'll take it later on. I'm going back to concrete. That is, I'm going back to best practices for cold weather concreting. Best practices for cold weather concreting. We discussed yesterday also. Let me repeat it. It's important. It's from Carbon Cure. Best practices for cold weather concreting. Just trying to repeat because it's important subject. Environmental factors like hot and cold weather concrete. Cold weather affect concrete properties. Affect placing and curing of concrete. Producers can adjust mix designs and compensate in a variety of other ways to maintain high quality standards and avoid issues with finished product. A concrete quality control veteran, Jack Haley, shares experience and comments best practices for hot and cold weather conditions in two parts. This is a simple definition we did yesterday also. ACI, this American Concrete Institute, defines cold weather concrete as a period. Cold weather concrete is a period when average daily ambient temperature remains below or expected to fall below 5 degrees Celsius. I am not speaking Fahrenheit. 5 degrees Celsius. If it is below 5 degrees Celsius, that is average daily ambient temperature. Falls below 5 degrees Celsius for more than 3 successive days. Average daily temperature is average of highest and lowest temperature during period from midnight to midnight. When temperatures above 10 degrees Celsius occur during more than half of day or any 24 hours duration, period shall no longer be regarded as cold weather. Cold weather concreting is when average daily ambient temperature is below 5 degrees Celsius for more than 3 successive days. Common mistakes with cold weather conditions. What is that? According to Jack, special precautions must be taken in cold weather to prevent damage to concrete. Necessary degree of protection increases as ambient temperature decreases. Necessary degree of protection increases as ambient temperature decreases. Common mistakes which we do, that is number one, letting concrete freeze. That is number one, letting concrete, that's a mistake. And then we have sending concrete out at improper temperature. Not monitoring temperature constantly, and we have improper placing and finishing. Mixed design adjustment in cold weather that we have to do, and we have reduced supplementary cementitious materials SCM and adjust admixtures, use accelerators, and you can say And we can say carbon cure and cold weather. So we go back and see these conditions which we say no, don't do that, start. And here is what we say, in fact. So we have understood what's cold weather concrete, average below 5 degrees Celsius, to be very frank, for 3 days. Then what is that? Letting concrete freeze. That's mistake we do, letting concrete finish. Concrete temperatures should be maintained between 10 degrees Celsius until expected strengths have been reached. Concrete temperatures should be maintained between you can say 10 degrees Celsius until expected strengths have been reached after finishing process. If concrete freezes prior to reaching an initial strength 3.5 MPa, if concrete freezes prior to reaching an initial strength that is 3.5 MPa, it shall not achieve its intended strength. It will not achieve its intended strength if it cannot have temperature, means if concrete freezes prior to reaching an initial strength that is 3.5 MPa, it shall not achieve its intended strength. Exterior concrete should be air entrained. Exterior concrete should be air entrained and at minimum required strength prior to exposure to freezing and thawing cycle. Further, fresh concrete closest to ground shall cure slower. Closest to ground means on ground, fresh concrete closest to ground or in contact with near soil shall cure slower than surface concrete, meaning top slab shall set while bottom stays soft, resulting in surface defects like cracking or crusting. Remember, sending concrete out at improper temperature. Need for proper planning in cold weather cannot be overstated. According to someone Jack, concrete should arrive at site on time and form from a production standpoint. Water and aggregates should be heated to maintain proper temperatures. One best way to do is with blends of hot water, warming sand, and even blending of sand in colder areas. Not monitoring temperature constantly. Mechanical and personal resources should be on site to monitor temperatures all time. One best way to do it is with a temperature calculator from ACI. Okay. Take temperature of all materials. Calculate output temperature of concrete. Target water temperatures and make other adjustments. There are temperature sensors. Target water temperatures and make other adjustments. There are temperature sensors available today that can be easily installed in concrete as it is placed. These sensors can send data wirelessly so that so can you supply. There are temperature sensors available today that can be easily installed in concrete as placed. These sensors can send data wirelessly so you can monitor and there are temperature sensors available that can easily installed in concrete as is placed. These sensors can send data wirelessly so you can monitor and foresee only potential users or changes in set time. Improper placing and finishing. Removing, heating and hoarding. Removing, heating and hoarding too quickly. Removing, heating or hoarding too quickly after curing period has ended shall cause a rapid cooling of outer surfaces. Improper placing and finishing. Removing, heating and hoarding too quickly after curing period has ended shall cause a rapid cooling of outer surfaces and create a thermal differential within placement. There are recommended time limits that can be referenced to through the point of removing, heating and hoarding too quickly after curing period has ended shall cause a rapid cooling of outer surfaces and create a thermal differential then we can say if these limits were exceeded, there is very high possibility that structure shall crack due to differential in temperature. Continue to monitor until differentials are equalized or at a small enough number that it won't create stresses within placement. For colder climates, it is best to remove it a day prior to removing heat to prevent freezing in a saturated situation, depending on how mature processed concrete is. Mixed design adjustment in cold weather. There are recommendations, mixed design making adjustments, so cold weather can be handled and following some producers will add 100, you can say some products as this is, if you add 50 to 60 kilogram per cubic meter, and that is your use of type 1 or type 2 cement, as we said, type 1 to type 5, type 1 and ordinary cement, and type 2 cement. Others, somebody add in that, high early strength cement, that is ground finer and it is faster. It is faster, so early. So early compressive strength gains are greater. However, none of these points are very efficient, cost effective for producers. Supplementary cementitious materials, cutting back on percentage of SCMs is common practice. But it will depend on application. For flat work, you need be a little more cautious and attentive with your initial sets. Adjoining admixtures, if normal water reducers had done, if normal water reducer had been elevated to near maximum limits for summer months, they should be moved back. Decreasing amount of water reduces retarder. Retarder is another common adjustment. That is decreasing amount of water. However, you don't want to decrease water reducing retarder past point of its moderate reduction, or you start the home workability return. Workability. However, you don't want to decrease water reducing retarder past point of moderate reduction. You start to have workability problems. Use accelerators. Only two types of accelerators: chloride based and non-chloride based. Chloride based accelerators are best, but they are limited due to corrosion potential of reinforcing steel. Non-chloride accelerators works well if manufacturers' recommendations for doses are followed. Carbon cure has been used for many years in cold weather. It won't contribute to any issues described above, nor shall it prevent either of them. While carbon dioxide is a cooling material, carbonic carbon carrier. Carbon cure has been used for many years in cold water conditions, and that is, it won't contribute any of issues described above, nor will it happen or prevent any of them. While carbon dioxide is cooling material, cooling Rinka material. Then we can say this chapter is almost over. You can see that what we are doing is the practice of concrete. So I did not take this into my account. We'll go back to next file, and that is this. When I close this file, we'll go to next one, and that's where it is. I will take another file now, and this is chemical reactions in polymer concrete. Let us see what it says. Okay, we will do this, and after this we'll take over. Okay, now I'm going to discuss about chemical reaction in pozzolanic concrete. Cement is most utilized construction material and second most consumed commodity in world. Cement is most utilized construction material and second most consumed commodity in world after water. Its demand has soared proportionally with exponential rise in population. With exponential rise in population in a bid to match required development. Heavily energy intensive processes that are involved in its production contribute to 7 to 10% of total global emissions with potentially adverse environmental implications and are also economically expensive. These processes and generally those of production of concrete consume heavily oil on natural resources. These processes and generally those of production of concrete consume heavily on natural resources such as sand, gravel, water, coal and crushed rock. Mining of which mars more environment. It's however possible that energy and cost efficiency can be achieved by reducing on amount of clinker and its place utilizing supplementary cementitious materials SCMs or pozzolans that requires less process. Heating and emit fair levels. You can say, or they require less process, heating and emit fewer levels of carbon dioxide. It says it's however possible that energy and cost efficiency can be achieved by reducing on amount of clinker and its placing supplementary cementitious materials or pozzolanas that require less process, heating and emit fewer Now we can say in this case, this paper elaborates on different types of chemical reactions that affect. Says a pozzolanic material relies on secondary reaction following hydration of cement. A pozzolanic material relies on secondary reaction following hydration of cement, whereby it reacts with free calcium hydroxide, to form a calcium silicate hydrate CSH phase, which major contributor to strength of concrete. Calcium silicate hydrate. As a result, there is usually you can say phase which is major contributor to strength of concrete. As a result, there is usually long-term strength development up to and beyond 91 days in pozzolanic concrete. Due to depleted levels of calcium hydroxide, pozzolanic concrete impacts superior sulfate resistance. You can say due to depleted levels of calcium hydroxide, pozzolanic concrete impart super sulfate resistance. It's also said super sulfate resistance. It's reported in literature that apart from environmental friendliness, use of supplementary materials such as pulverized fuel ash, ground granulated blast furnace slag, GGBS, silica fumes SF, metakaolin MK, and rice husk ash RHA reduces cost of concrete and improves properties, durability of hardened concrete, thereby enhancing service life of structure. That's what it is, and discuss about this. Cement is deemed to have a considerable high carbon footprint, contributing immensely to global anthropogenic carbon dioxide. Climate change is purported to be a phenomenon that can bring about rise in global temperature due to presence of excessive carbon dioxide in atmosphere and is cumulative and irreversible over time scales of centuries. Burning of fossil fuel in this case for production of cement contributes to greenhouse gas effect, which is a major cause of climatic change. Even though heavily energy intensive cement is pivotal to development and is produced in virtually all countries. 1 ton of concrete on average is produced every year for each human being in world. A population that currently stands above 7 billion or 8 billion, growing population matched by corresponding increase in demand for socio-economic infrastructure that's aimed at creating affluent society, especially in developing world and formal socialite countries, has led to a gradual increase in demand for cement in past few decades, with construction investment directly linked to higher gross domestic product. Cement was described as salami and cell. We can say a considered high level of emissions when compared to 2% total global emissions attributed to aviation industry. Production of a ton of cement emits approximately a corresponding ton of carbon dioxide, making it most energy intensive materials produced after steel and aluminium. Cement section elaborates on production process in as much as development is required to match increasing populations, which also is sustainable. Underlying principles of sustainability lie in appropriate balance of economic, social, and environmental impacts. It defines sustainability as road for society development in which progress must be in harmony with natural world rather than in conflict with it, while Gambhir termed it as a regime in which endeavors are towards meeting needs of present generation without compromising those of future generations. With a heavy demand for concrete in developing world and other major and equally populous economies such as China and India, predicted cement producing companies have not anticipated in foreseeable future any major changes in production that reduces emission. However, energy efficiency can be achieved by reducing amount of clinker and utilizing SCMs which require less process heating and emit fewer levels of carbon dioxide. Now, the tables will discuss. Table shows embedded carbon dioxide values of our main constituents of reinforced concrete. It shows embedded carbon dioxide for both PFA, as known as fly ash, and GGBS is substantially less than EMA. Industrial and agricultural waste products such as PFA, GGBS, SFRHA, and CCA unnecessarily occupy space when stored or create environmental hazardous and dumping in land. Utilization of construction industry reduces overall cost of construction, mitigates on technical and environmental nuisance that is associated with production of cement, reduces solid waste, cuts on greenhouse gas emissions and conserves existing nature. Utilization construction industry reduces overall cost of construction, mitigates on technical and environmental nuisance that is associated with production of cement, reduces solid waste, cuts on greenhouse gas emissions, and conserves existing natural resources, thereby enhancing sustainability as well as improving property. Concrete is very versatile material with important properties such as strength, durability, versatility. Affordable and fire resistant and thermal mass. Furthermore, it's locally produced and utilized in all countries. Most common type of cement which is used in combination with other materials to form different types of concrete is Portland cement. Portland cement is produced by burning a mixture of calcium carbonate, that's called lime chalk, and aluminosilicate clay or shale, and then product is ground with approximately 5% gypsum to produce cement. Cement is material which binds together solid bodies, aggregate by hardening, form plastic state. European standard specification in 1997 categorizes cement generally available in Europe into 5 main types. Cement type 1 and type 2. Type 1, that's CEM, Portland cement, contains 5% secondary sand, supplementary constituents. 5% secondary sand. Cement type 2, Portland composite cement up to 35% of other ingredients other than OPC. This type 2. that is PFA or limestone. So cement 1 is 5% secondary sand. Cement type 2 is Portland composite up to 35% of other ingredients other than OPC, and that's PFA or limestone. And cement type 2, that is type 3, sorry, blast furnace slag cement comprising Portland cement and higher percentage of blast furnace slag than cement 2. So type 3 is GGBS, you may say. Type 4 is pozzolanic cement, includes Portland cement in the greater proportions of pozzolana than cement 2. And cement type 5, composite cement, mix of Portland cement composite specifications and conformity criteria for common cements. Then we have the cement production. We'll take it later on in this file. I'll take it later on, and I think this file is, let me see which file is this. This is concrete chemical reactions. We'll take up later on, and now I think we have to, we'll close it for time being, and we'll do it later on. Let us now